grade 11s, welcome to Tuesday morning, May the 26th. As we get started today, let me start you off with a verse of the day. Again, it is from the book of John, chapter 15, verse 13, where it says, "Greater love has no one than this, to lay down one's life for one's friend." And so again, just a reminder to make sure that you love one another, love those around you, and be servant-like in your attitudes towards people. So just again, be encouraged by that, and yeah, let's get into it. All right, today we want to talk about, again, we're continuing with our discussion about reflections. All right, light rays being reflected. And so today we want to talk about reflections in plane mirrors. A plane mirror is simply a flat mirror, the kind that you would look into probably at least once every day. You can see your reflection in a mirror. And then as we get into it in the coming days, we'll do what are called convex and concave mirrors as well. So we're going to start, again, it's just a simple diagram that we have to do, and there's no real formulas in here, but there's some principles that we have to adhere to. So what I've drawn is I've drawn a mirror here, and on one side I've drawn the mirror flat, and on the other side I've drawn whatever squiggly lines on the back, and it's just to indicate front versus back of the mirror. If you label it properly, it doesn't really matter what your mirror looks like, but here on this side I've got an object, and on the other side I'm going to get an image. All right, and so here you'll notice I've labeled this, the distance from my object to the mirror, as DO for distance object, and up here I've labeled this HO for height of the object, because what we're going to get down to is when we have objects and images, we're going to be comparing the object to its image, and there are some quantities that we want to be able to make reference to, two of which are height and distance. All right, so what we do when we draw, figure out what the image is going to look like and where the image is going to be, is we again use our properties of reflection of light, which simply means that the angle of incidence equals the angle of reflection. Now, in order to see anything, it's because light comes off of the object that we're looking at into our eyes. So what happens here is light comes off of this object. So let's draw a light ray that comes off this object. Okay. And now we're only going to draw a few select light rays coming off this object. In reality, there's an infinite number coming off in all directions, and a certain number of those ones are coming into our eyesight and allowing us to see it. All right, so if I have this light ray coming this way, it's going to get reflected, again, in such a way that the angle of incidence equals the angle of reflection. So, like that. Okay? So that's how that gets reflected. But how do we see an image in a mirror? Well, because of the mirror properties, what happens is this line gets extended backwards like so. And I'm going to draw that a little straighter and a little better. Okay, it gets imagined that way. Okay, so it's an imaginary line that goes in behind the mirror from the reflected ray. Okay, if we do another one, let's say we take another light ray and we do this, and it comes off here, and then here is its normal line, and it's going to get reflected like so. Okay, and then it gets projected in behind the mirror, and then we get this where it crosses right there. That would be the tip of the arrow. And if we do this from every point, let's do it from, I'm going to erase this one for a bit. If we go from the tail here, and I do the same thing, if I draw a line like this, it's going to get reflected like this, and then projected this way. And if I do another one, let's do one that goes straight in and straight out. Straight in, comes straight back, gets projected this way. There's the tail of my arrow, and it would look something like that. Okay, if you can see that. Okay, I'll color it in for you. There is my arrow. All right, and so that's actually not bad without doing it with rulers, etc. I got a pretty good image, and what we should find is that when we calculate our di for the image distance, what we should find is that for plane mirrors, do equals di. Okay, now I'm going to add a negative sign in here. Okay, and that negative sign is important because, again, it's just a convention that we're always going to use, and that is distances that are on the object side of the mirror are going to be positive distances. Distances that are on the image side of the mirror are going to be negative. Okay, and that will be something that continues as we get into the different types of mirrors. Okay, so di will equal, or do will equal negative di. The negative is just telling us that it's on the back side of the mirror. What we would also find is that the height would be the same. So HO would equal to HI. The height of the object would equal the height of the image. Okay, but the key point here is being able to draw the lines. Okay, so again, remember that light comes off of the object, reflects off the mirror, following the law of reflection, that angle I equals, or theta I equals theta R, and then it is the reflected ray that gets projected into the mirror, behind the mirror, if you will. Okay, and if we do that for enough spots, for all the, if we could do it for all the spots, we would get a perfect image. Here we just did top and bottom, and we got a pretty good image. And that's usually fine when we're drawing these things, to pick a few key spots, draw them, and then see what happens. All right, but these are important because these are principles that will hold because they are not dependent on how well we draw our diagrams. All right, and your diagrams only need to be as good as mine when it comes to it. Sometimes using a ruler would make it easier and give you some better lines, straight lines anyway. So I recommend that, but you don't have to use a ruler. Now, on the side of the board over there, I wrote down this statement here, real versus imaginary images. Okay, and so this is something that will become important as we move into concave and convex lenses, and again, it's part of our description of an image. So when we're describing an image, we're going to describe it in terms of where it is, how high it is, whether it's real or imaginary, and then also whether it's upright or upside down. Okay, and again, if you've ever looked into a spoon, if you hold up a spoon, look at your reflection in it, one side, your reflection's right side up, the other side, it's upside down, so we're going to talk about whether it's upright or upside down. So, but real versus imaginary. What this means is that a real image is in front of the mirror. Okay, and you might say, well, how does that work? Well, essentially, it's a hologram. Tomorrow, when we start looking at curved mirrors, I'll bring a hologram into class here. I don't know if you'll be able to see it on the video or not, but we'll try to make it work. But if you've ever visited my office in the last couple of years, I have a hologram mirrors thing in my office where there's a real image that is in front of the mirror. It looks like the object is actually sitting on top of the mirrors, but it's not. It's actually sitting inside of a bowl that has reflective surfaces inside of it. So it's a mirage. It's a hologram for the words. All right, so that's our real images, where the image is in front of the mirror. And we'll see some when we do some curved mirrors where we can get this image to be on the same side of the mirror as the object. All right, and then an imaginary image is just the opposite. An imaginary image is like what we drew here, where the image is behind the mirror. Okay. So an imaginary image is behind the mirror. All right, so that's the difference between real and imaginary. So if I was describing this image using 4 categories that we're always going to use, okay, we would say that the image distance is the same as the object distance. The image height is the same as the image object. We would say that it is an imaginary image, and we would also say that it is upright. okay, that the orientation is the same. All right, so that's how we're going to describe images when we get into it. We'll write more of this down over the next couple of days, but those are 4 categories that we're going to describe images using. And again, there will be a couple more formulas as we move into concave and convex mirrors. All right, we're going to leave it at that today. You're going to find an assignment in your textbook that you'll find on Connect. Again, just a few questions using law of reflections, angle in equals angle out. And that shouldn't be that hard, but if you have questions, make sure you ask me, send me an email, and we'll answer those questions. And again, tomorrow we're going to move on to curved mirrors and see what difference that makes. So hope you have a great day, and we'll see you tomorrow.